Hi guys, so we will proceed with tutorial 4.2 type of functions. So let's talk about the notes. So in 4.2 we will learn on how to sketch a constant function, linear function, quadratic function and surd function. Okay, this is a basic shape of constant function. It's a horizontal line passing through y-axis. And then another graph. This is actually a linear function, a linear graph, because it is a straight line. Okay, still remember the equation? Y equals to mx plus c, the one that you learn in your secondary school. Okay, but this one special case, we call it as identity function. Why? Because fx equals to x is actually y equals to x. Alright, so moving on to this one. This one is a squaring function, or well known as quadratic function. Quadratic, you knew already that the graph will be smile graph or set graph. Okay, so this is the new one for you, square root function. Square root is actually surd function. Okay, so fx equals to surd x. The graph is like this. It's actually a curve almost similar to half of the graph for quadratic function, half. But quadratic function, we knew that it open upward or open downward, smile or set graph. But square root or surd function, open to the right or open to the left. Okay, let's focus more on our example.
Alright guys, so 4.2. So now we are going to learn how to sketch a constant function. Why? Because the function given to you is in this form, fx equals to c. C here is given to you minus 2. And this one is a linear function. Why? Because this one is actually similar to fx equals to mx plus c. Or fx, you can replace it with y. Y equals to mx plus c. Alright, so how do we sketch this one? This one is a constant function. If the question asking you to sketch, the first step is to make sure, draw axis. Make sure you label your axis x, y, 0, 0, origin. Okay, take a look at minus 2. Where is minus 2? Guys, be careful. This one is actually similar to y equals to minus 2. Why? Because fx is actually y. So if fx equals to minus 2, so y equals to minus 2. So where is it y equals to minus 2? We knew already that somewhere here is 0, going up is positive, going down is negative. So going down 2 units, you will get minus 2. So minus 2 is somewhere here. This is minus 2, right? This is minus 2. So where is the graph? Fx equals to minus 2 is actually a straight line. Straight line, okay? Horizontal line, because this one is constant function. Horizontal line means that this way, therefore, this is your graph. So fx equals to minus 2. So this is your graph. So let's proceed with linear function. So how do we sketch this one? First of all, draw your axis. Don't forget to label your axis always, and then your origin. So how do we get the straight line? Easily guys, m is minus 2, right? Your m is minus 2, your c is 4. What does it mean? Once you have your c straightforward, you know that your c is actually a y-intercept. 4 is positive, so going up 4 units, you will get 4. Somewhere here, 4. Here, you will have a point of the straight line. You just need another point to draw the straight line. So to get another point is by letting something becomes the x. For example, let x equals to 2, for example. So what happened when x equals to 2? This is y, guys. Y equals to minus 2. Substitute the x that you let just now. 2 plus 4. And then you will get y equals to minus 4 plus 4. Y is actually 0. So what does it mean? These two combined will be a coordinate for the next point on the graph. So the coordinate is x2, y0. x2, y0, 2 units to the right. So somewhere here maybe. So here will be 2. So once you obtain these 2 points here, you can simply draw a straight line. You can simply draw a straight line. Not too straight. So this is the straight line of fx equals to minus 2x plus 4. Okay guys, in subtopic 4.2 as well, they want you to find domain and range for the given function. We can denote it as df. As I told you before, domain is the possible x values for the graph. X values, possible x values means that horizontally, where do you have your graph? Starting from minus infinity to infinity, right? So that's why the domain of constant function is always minus infinity to infinity. So this is the domain for constant function. How about the range? Range for constant function. So or we can denote it as R sub f. Why f? Because this is f. If this one is g, so rg, dg. Okay? dg. Alright. So range rf. Range is the possible y values for the graph. As you can see, this is the graph, and then you have just one value of y that having the graph, which is minus 2. Is there any graph that at 0? At minus 1? There is no graph, right? This is minus 1. At y0, is there any graph? No, right? So your graph have at the value of y minus 2 only. So that's why your range is minus 2 only. So let's proceed with the domain, finding the domain and range for linear function just now. So this is the graph that we obtained from the linear function. Okay, so the domain of this function, as I told you, domain is the possible x values for the graph. And your graph is actually extend this way. Okay, so that's why your domain is minus infinity to infinity. Why minus infinity to infinity? The domain is the horizontal part of the graph, starting from minus infinity to infinity. So moving on to range. So range is the vertical part, starting from where to where. Okay, possible y values for the graph to be. Okay, as you can see, the range will be minus infinity goes to infinity as well, because vertically it will start from minus infinity to infinity. So these two always the domain and range for whatever function that you have for linear. Moving on to part C on how to sketch and finding the domain and range. But this time for function fx equals to minus 2x squared plus 3x minus 1, which known as quadratic function. Okay, so how do we solve this one? First of all, we can take a look at the A part. This is A, this is B, this is C, right? So your A is minus 2. So once you see that your A is minus 2, you knew already that this is a set graph. Okay, so and then take a look at your C. Your C is minus 1. So what does it mean by C minus 1? C minus 1 here is your y-intercept, always. Okay, and then what happened next? You knew already the basic shape of the graph, you knew already the y-intercept, one of the point for the graph. And then, by using your calculator, calculate your EQN. If you still remember, calculate your EQN, you will get that your x will be half n x equals to 1. This is by using your calculator, EQN. So this 2 is actually your x-intercept. Okay, let's sketch our graph. Don't forget to label your axis, y-axis, x-axis, and origin. So let's plot this one, y-intercept. Y-intercept minus 1, so y-axis minus goes downward 1 unit. Let's say 1 unit somewhere here, 1 unit. Okay, and then by looking at your x-intercept, x half and x1, so this is your x-axis, positive, positive, goes to the right half unit and 1 unit. 1 unit is somewhere here 1, somewhere here 1, and then half unit is somewhere here, half. Okay, y-intercept and x-intercept is actually points for the graph to be. The graph will passing through these 3 points. So you knew already that this is a set graph. To pass through these 3 points, somewhere here will be the maximum point. Maximum point. So then this is your graph. So this is your graph. It should be a set graph passing through your y-intercept and x-intercept. This is the graph of fx equals to minus 2x squared plus 3x minus 1. Okay, so now let's obtain our domain and range. Alright, domain is the possible x values for the graph. So what does it mean? Horizontal values of the graph. Horizontally, your graph starting from where to where? Guys, please bear in mind that this one is extend infinitely. So then, horizontally, it starts from negative infinity to infinity. So that's why the domain is minus infinity to infinity. Or you can make it real numbers if you want to. If you're not familiar with this one, you simply write down minus infinity to infinity. Make sure you use this bracket only, not the other brackets. Okay? Alright, so let's find out what is our range. To get range is the possible y values for the graph. In other words, actually the vertical parts of the graph starting from where to where. We knew already that the graph starting from negative infinity because this line here goes downward infinitely. So it goes from minus infinity up to this line. Up to this line. Right? So it starts from minus infinity up to this line. Up to this point. So but how to obtain the highest point? To obtain the highest point, guys, this is slightly difficult because we need to do completing the square. So then this is let me eliminate this one first to make it clearer for our calculation. So now we have y equals to minus 2x. I change fx to y to make it easier. 3x minus 1. Guys, we need to do the completing the square for this one. To do completing the square, you need to make sure that this one is 1, not the other number, positive 1. So since this one is minus 2, therefore we need to factorize it. Minus 2x squared minus 3 over 2x, and then close the bracket, minus 1 here, leave it as minus 1. So the next step is to do the formula of completing the square. Big bracket square minus small bracket square. Minus 1 remains similar, minus 1. So fill in the blank here. X is X, minus is minus. 3 over 2, this number here always divided by 2. 3 over 2 divided by 2 is 3 over 4. Take this number 3 over 4, bring it to the other bracket. That's how you complete the completing the square. Alright? So then you can proceed. Minus 2. Simplify. X minus 3 over 4 square. Minus 3 over 4 is actually minus 9 over 16. Minus 1. Right? So let's extend. Let's expand. Minus 2. X minus 3 over 4 all together square. And then expand this one as well. So what do you get? Negative, negative. Minus is plus. Positive. 2. 16 can be cancelled off. So leave us with just 9 over 8 minus 1. Ready? So 9 over 8 minus 1 is actually 1 over 8. 1 over 8 here. 1 over 8. I simplify it all together. Okay? So 1 over 8. Guys, what is this number? The number here is actually 1 over 8. Similar to this one. So to get the maximum or the minimum parts of quadratic graph, you need to do the completing the square. So the last part here is actually the maximum part or the minimum part. Depends on the function given. So this somewhere here is 1 over 8. That's why this one is going to be 1 over 8. But be careful guys. 1 over 8, it touch 1 over 8. It touch it. So you cannot make it open bracket. You need to make it close bracket instead. So this is the answer of domain and range for quadratic function. Alright guys, moving on to part D. Still sketching and finding the domain and range for the cubic function. Alright. Forgot to tell you about the cubic basic shape of cubic function in the notes. So let's focus on the whiteboard here. So cubic function actually have 4 shapes. Okay, so this is the basic equation of cubic function. Fx in the form of ax cubed plus bx squared plus cx plus d, where this one is going to be your y-intercept. Alright guys, almost similar to the quadratic case. What we need to know that A representing the shape, the basic shape of the graph. If A is positive, alright, if A greater than 0, if A is positive, means that the graph either going to be this one or this one. We have 2 options for positive graph. Okay, I will tell you the difference later. So if A is negative, is going to be this way or this way. You can take a look at the shape. Positive, lower left to the top right. That if A is negative, top left to the lower right. Okay. Alright, so this one, these two happens when no B and C. Where is, take a look at the equation given to you. If there is no B and C, so these two will be the basic shape. If there is B and C, so it's going to be these two. Either this one or this one. So take a look at the equation given to you. The function given to you is x cubed minus 1. So means that there is no B and C. Leave you with just A and D. Here you have your A is 1, your D is minus 1, right? where B is 0 and C is 0. So since there is no B and C, your B and C are zeros. So what does it mean? It's either this one or this one. Among these two only. And then by looking at A is 1, so this is your basic shape. Alright? So that's how we distinguish between the shapes of cubic function. Alright, so then we knew that the shape is this way. And then the y-intercept, this is your y-intercept. You can draw the graph already. So y, x, 0. Your d is -1. So -1, let's say somewhere here is -1. Okay, guys, if this is the graph, -1 will be somewhere here, guys. -1 will be somewhere here. Here is your -1. Okay, so the graph will be like this. It will be 0 gradient at -1, and then it will turn upward. Okay, so this is the graph of fx x cubed minus 1. To get the domain and range for the given cubic function, domain, this one is slightly easy. Domain, as you knew already, the possible x values for the graph, or horizontally your graph starting from negative infinity to infinity, right? Because this one extends infinitely. So horizontally your graph starting from minus infinity to infinity. And guys, same goes to your range, starting from minus infinity to infinity as well, because range is for y values. Vertically, your graph starting from negative infinity to infinity. So these two always the answer for domain and range for cubic function. Part E, we will talk about function to third x minus 1, which known as third function. So for your syllabus, restricted to linear only. So linear means that in the form of mx plus c. Okay, so it's going to be easy. But the trick for finding the graph is under your set. That's the trick. What is your under the set? Inside the set, under the set, inside the set, maybe inside the set you have x only, right? So make sure, take whatever it is inside the set, and the trick is to let it be 0. Whatever it is. If inside the set is x plus 1, so make it x plus 1 equals to 0. Here we have x only, that's why let's make it x straightforward equals to 0. So you knew already when x equals to 0, let's calculate what happened to y. So fx, let it be y equals to 2. Set x is 0, so x here we replace it with 0, and then minus 1. What do you get? So you will get y equals to minus 1. So these two combined becomes a coordinate of a point. Okay? Just plot this point. Where is it? 0 minus 1. So 0 minus 1 is somewhere here. 0 for x, minus 1 for y. This is the point. So where is your graph going to be? You knew already that the basic shape of set, this is your graph, right? No matter what happened here, what happened do you have here, it will still be this shape. Okay, if you have another add-on at the back here, the shape is still similar. But the one that I teach you just now, to get this point always representing the starting point of your set graph. So since this is the point, so where is the graph? The graph is going to be like this. It will not go down, it will go straight horizontally infinitely. So this is the graph of fx to set x minus 1. So let's find out what is the domain and range for the graph. Okay, domain is the horizontal part of the graph, starting from where to where. So the domain starting from horizontally, starting from this line to infinity, right? To infinity. We knew already that it will end up at infinity. So what happened here? It's starting from where? Starting from x value, right? So domain, we are talking about x values. The x values is 0. 0. The x values is 0. So that's why 0. And then please be careful about the bracket. The bracket 0, it touched the coordinate of 0 minus 1. Here is the coordinate of 0 minus 1. It touched the 0. That's why we need to do a close bracket instead of open bracket. So this is the domain. So proceed with range. Where is the range? Range is for y values. We are talking about y values. Vertically, where do you have your graph? Vertically, you have your graph starting from this point upwards, right? This is where you have your graph offset. So then it starts from minus 1, close because it touched at the point of 0 minus 1. Close goes upward, goes to infinity. Infinity and minus infinity always open. So that's it. We have done already with 4.2. Try to do your tutorial, your questions.
Thank you